Good morning, everyone. This video we are going to cover section 5.5. I plan to do 2 videos for this section. Each video I hope could last like only 15 to 20 minutes to guarantee that the content will not be compressed. Section 5.5 Exponential and Logarithmic Equations. We have a formula. Here, log with base b of star equals triangle. You know I like to use star or triangle to represent quantities, right? So this is an equation. This equation is in the logarithmic form because you see a log on the left-hand side. There are 3 parts in this equation. We need to know the names for all the 3 parts. B here, by the foot of G, log. B here is the base. The name for B, part B, is the base. And the star here is called anti-logarithm. And the triangle represents the whole logarithm. There are 3 parts in this equation. They are base, anti-logarithm, and logarithm. This equation is in the logarithmic form. And this equation could also be written in its equivalent exponential form. And how do we convert the equation from logarithmic form to its equivalent exponential form? This is how do we translate or convert. We take the base b, raise the base to the power of triangle, which is the log. That equals the anti. I use this trick, we pretend that B is a person. The person's name could be Bobby or Beth, anybody. B is a person. And logarithm, L-O-G. This English word also can represent a piece of wood, right? You know the log cabin? A log cabin is made of those logs. So log can be seen as a piece of wood. So you can imagine in your head, picture a person B. The person is carrying a log on its shoulder. And that might be a good reminder that how do you convert from the logarithmic form to its equivalent exponential form. You take the base b and then raise the base b to the power of log. He's carrying a log and equals the anti. We only have 3 parts. If you have used the base and the log on the left, then on the right hand side, of course, you have the anti-logarithm. Okay, so this is a very important formula. Those 2 equations are the same equation in different forms. This is the equation in the logarithmic form. This is the equation in the exponential form. We need to know how do we convert an equation from logarithmic form to its equivalent exponential form, and vice versa. How do we convert from exponential form to logarithmic form? Well, let's see how do we apply this fact or formula to solve exponential or logarithmic equations. Let's see the example 1. I will read the requirement for example 1. It's in my note. Solve equations. Write the answer as both an exact expression and as a decimal approximation. Number 1, we have 10 to the power of 6 over x equals 321. Let me double check. 10 to the power of 6 over x equals 321. Here, x is non-zero. Obviously, x has to be non-zero because x is the denominator of the exponent on the shoulder of 10. Denominator can never be 0, right? We know that. Okay, so let's see, how do we solve this equation? What kind of equation this is? This is an exponential equation, but it's not an elementary exponential equation. From previous video, you should see how do we solve an elementary exponential equation. What kind of equation is elementary exponential equation? When both sides of the equation could be written as the power of the same base. Technically, this kind of equation could also be written as the powers of the same base. However, it's not very convenient or straightforward. So this is not an elementary exponential equation. Left-hand side is a power with base 10. Right-hand side is 321. We don't really see the connection, or we don't really see it's easy or convenient to rewrite 321 as something as an exponentiation with base 10, right? So this is not elementary. So we need to use or apply a different method here, approach here. This is how do I solve this kind of exponential equation. Since the base on the left-hand side is 10, I am going to apply common logarithm on both sides of the equation. We talk about common logarithm, right? Common logarithm. Common logarithm is a logarithm with base 10. So if you don't see a base here, that means the base is default as 10. And we call that logarithm common logarithm. A function is kind of like an operator. If we have an equation and we treat both sides of the equation the same way, like what I just did, I apply the operator or function common logarithm log on both sides, then the equation would remain the same. Then now let's see what will happen after this step. On the right, we have log 321. On the left, we have a common logarithm with base 10 to the power of 6 over x. The anti is a power. Do you guys remember the power rule? Power rule, let me write it here. Log with base b, x to the power of r. If the anti is a power, we are able to move the exponent r in front and then multiply by log with base b of x. So we are going to move 6 over x. I'm using black here, right? In front, and then multiply by log 10. Once we move 6 over x away, in front of the logarithm, there's no exponent on the shoulder of 10 anymore. That is the power rule. Okay? Yeah. Question, what is log of 10? What is log of 10? 1. If we have a logarithm, the base and the anti are identical, then the value of the logarithm equals 1. You can remember this. I want you please remember this as a formula, this equation or fact as a formula. If we have a logarithm, the base and the anti are identical, then the value of the logarithm equals 1. So you would know common logarithm of 10 equals 1. If you try to use your calculator, you would have the same thing. Log 10 equals 1. So we would have no, this part would be 1. So we can just get rid of it. And we would have 6 over x times 1 equals log 321. Right? This is a rational equation because x the variable x is in the denominator. How do we solve that? X. So there are different methods. The way that I'm going to approach this is I am going to take the reciprocal. I am going to take the reciprocal of both sides. Okay? Right hand side is log 321. I could rewrite it as a fraction, common logarithm of 321 over 1. And then I flip the left hand side. Take the reciprocal. Also flip the right hand side. Take the reciprocal. As I mentioned earlier, we have an equation. As long as we apply the same treatment to the both sides of the equation would remain the same. And let's see. On the left, now we have 1 over 6 times x. Right hand side, we have the reciprocal of a common logarithm of 321. How do we get rid of the 1 over 6? 1 over 6 is the coefficient of x. We are going to multiply both sides by 6. Then those two 6 are cancelled out. X would be isolated on the left hand side. X equals 6 over log 321. 321, right? So that's how do we solve the given equation for x. 6 over common logarithm of 321 is the exact answer or value for x. What if we need to approximate, find the decimal for this problem? Then you try your calculator, okay? Try your calculator. Did I show you how do you use your calculator to evaluate a common logarithm? Is it bright enough? Clear enough? So we would have 6 on the numerator divided by common logarithm 321. Remember to close the parentheses. Rid of the parentheses. We distribute with ln5. We have 3 times ln5 break expression. So 3 times ln5 times x and then plus ln5. 3 terms in the equation now. 2 of them have x, the other just a constant. So now I'm going to move 3 times ln5 of x to the left. Move it and change the sign. So move it over, negative 3 ln5 x equals ln5. This way, we collect the two like terms. We know they are like terms. We would have to collect them before combining them. How do we combine them? We combine their coefficients. 4 minus 3 ln5 x equals ln5. So the coefficient of x is whatever the number inside the parentheses. In order to isolate the x, to solve for x, we divide both sides by 4 minus 3 ln5. 4 minus 3 ln5. Okay, so they cancel out. X is isolated by itself on the left. We have x equals ln5 over 4 minus 3 ln5. Now bring in your calculator. Evaluate the expression. You would have a negative number. In this case, x is a negative number. I'm going to skip this part, okay? Number 3. Let's see if we can do one more. So I'm going to stop here and start the next part of this video. Because I'm so afraid that if I make the video very long, part of the content, especially the end of the video, is compressed. That's a big waste. So this is a part 1 of 5.5.